Hello once again and welcome to another episode. This video is an introduction to logic gates. There will be more videos in the future to cover more of the different types of logic gates and different circuits that can be made using logic gates. Now before we go ahead, I just want to explain what logic gates are. If you've never heard of a logic gate before, or if you just want to know more about them, then basically a logic gate is the fundamental building block to digital electronics. A logic gate can be used to activate an output based on its input conditions. Now, most logic gates consist of two inputs and will give one output depending on the condition of its inputs. So for this example, I have an AND logic gate. And what this means is it will give an output if input 1 is high and input 2 is high. And what do I mean by high? Well, by high I mean above 0 volts or above its logic high threshold. Now for this logic gate and most other logic gates, a logic high is 5 volts. A logic high can be 3 volts or any other voltage which can be specific to any type of logic gate. Referring to the datasheet will tell you what the logic high threshold is and what the logic low threshold is. But for this example, to keep it simple, this logic gate is set to have a logic high voltage of 5 volts. A logic low is generally 0 volts or near to 0 volts. So basically this logic gate has two inputs and the output is connected to an LED, so the output of this logic gate is the positive side and then it's going to ground. So before you ask any questions, don't get confused. This is it's a circuit simulator, so how you see it here is a very simplified version of how it would actually be set up. You would see a power supply there as well. So we would clearly have a power supply with a positive and negative on the output. But this is a very simplified circuit, so don't get confused by that. Just focus simply on understanding the logic gate side of it. So we're going to play this circuit, and as you can see, no current is flowing through the LED on the output. It's not letting any current flow through. And that's because our logic inputs to this logic gate are completely off. Both of them are on a logic low or 0 volts. Now if we turn one of the logic inputs on, nothing happens still, and that's because this is an AND gate. So what it requires is both input 1 and input 2 to be active for a logic output or for a logic high to occur. So if we then enable the second logic input, we get a logic high because input 1 and input 2 is active, and therefore our LED on the output now lights. So that is the basics of an AND logic gate. Let's go and have a look at the OR logic gate. You can probably guess what's going to happen with this one. If we play this circuit, we have the same setup, except this is an OR gate. We have exactly the same inputs, so we have two inputs and one output. But because this is an OR gate, if I enable one logic input, we already get a logic high and we get an output to our LED on the output of the logic gate. And this is because it's an OR gate, so for an output from our logic gate, we only need a logic high, or one of the inputs, to be active. So input 1 or input 2 can be active. What about if we activate both of them? Nothing changes, because one of them is still active. It's an OR gate, so it doesn't matter if both of them are active. It's just if one of them is active, then we get a logic output. If we disable both of them, neither channel 1 or channel 2 is active, so we don't get an output. So we're going to look into more logic gates and dive deeper into how they work and even build circuits with them in the future. But hopefully, just for now, you get a grasp on the AND and the OR logic gates. If you have any questions, leave them below in the comments, and if you have any suggestions for future videos, do leave them below also. Hit like, subscribe to this channel if you want to see future videos. There are many videos that you can look into on this channel, and give this video a thumbs up.
Young English Engineer. Your way to the electronics world. Like our Facebook page and learn more. Project provided by Tesla Institute. School of Electrical Engineering and Automation.